Hello everyone, welcome to the channel, and today we're going to discuss question number 9. Swap all odd and even bits in bit match of must-do coding questions in Geek for Geeks. Just have a quick look at the question, and after that we're going to approach. Before that, please don't forget to subscribe. Now coming to the approach, let's understand the question first. What is the meaning of the question here? So the question is telling us there is a number given which is 23, and the binary format of the 23 is this one 010111 is a binary format of 23. What this question saying is we have to swap all odd bits with the even bit. For example, I will be marking the odd bits with O. Okay. So starting with 0, we will regard this as an even one. Okay. So because the index starts from 0 like this, and 1, 2, 3, 4, and 5. Okay. So starting one would be regarded as the even bits here. Now let's take a different color for that. So this 0 is even. Okay. So let's take even first. E, this one is E, and again this one is E, and this one is E, and there are no other E's. So how many E's are there? 3 E's. Let's take those values at this position, which is 0, 0, 0. So this is 1, this is 1. So rest of the bits you can fill with 0. It will be 1 bit less here, so that is fine. So 0, 0. Now filling the rest of the bits with 0. Now we have total 6 bits, right? So this is the even bit position number. You will know what is the use in just a moment. For now, just follow the question, what I am saying. So these are the even bits here. Now similarly, if we take the odd bits, let's represent it with another color. Let's take a yellow color here. So odd bits are the bits which are remaining. Of course, the bits which are remaining, this one, and this one. These are odd now, okay? And we'll write down below. Okay, that will be 0, and odd one is 1 here, and again 0 is in between here. So the odd bit is 1 here again. So the bit which we are not taking, that in that place you have to keep 0. This will be 0 and this will be 1. So this is the odd bit position, right? This is the odd bit position. Now we have to swap the positions with the even bit. How will we do that? How will we swap that? We will be swapping those by taking the by doing OR operation. But before doing the OR operation, we have to shift this, okay? Because we are swapping this bit with one place, okay? Even have to shift right side and not have to shift left side, okay? After shifting this even bit, we'll get a number 0, 0. We'll actually get 1 as a value here for the even bits, okay? 0, 0, 0, 4 zeros are there. Now actually we have shifted one bit, okay? Every bit will shift to the right side here. We have to shift one bit, because by doing that we leave a one bit extra. Okay, we have already shifted all the bits to the right side. Now if we shift odd bit to the left side, similarly if we shift odd bits to the left side, okay, if we shift this odd bits to the left side, odd bits will be in the position of even bits, and even bits will be in the position of the odd bits. Now both of them have been swapped. Now both bits have been swapped now, okay? After swapping all the bits, so this is the after swapping, this is the even bit, and after the odd swapping here, now we have to shift the left side, okay? Only one time we have to shift one time. So what will be the answer? You have to think, okay? After shifting this, here we get 1, 0, 1, 0, 1, and 0. Yeah, you can see carefully here. If we shift one bit, so 1 will become here, the 0 will go to this place, and similarly this will continue here. This will continue like this. After shifting all the bits, we get this odd value place, okay? Now we have shifted the bit position. Okay, we have shifted the bit position. Now odd bits are shifted to the right position, and even bits are shifted to the odd position. They have been shifted. Only the even and odd bits are shifted separately. Now we have to combine those. How we combine it? We use plus symbol. By plus symbol, it means we are doing OR operation. We are doing OR operation here. If we do OR operation, we will get 1, 1, 0, 1, 0, and 1. Okay. This, if you convert this into decimal format, this will be equal to 43. And this is our output here. So this is what the meaning of question. So we have to take even bits and we have to take odd bits. Now we have to shift them, okay? This is the meaning of the question by shifting left and even and odd bits, okay? Now we will take another way to this approach, okay? In theory, we can say these are the odd bits and these are even bits, and we can understand it like this. But while doing coding, we have to use this 0xAAA and 0x555, and we'll be discussing this after erasing this. We will discuss, okay, when we will get the same answer using that. Okay, now so first let's see what is this 0AA means. 0AA means simply 1010, and this is the 10 format. Okay, it will continue like this in 101010 and so on. Okay, similarly 0x A555 means 0101. Similarly this will also continue 0101 and 01. Okay, what is the use of this? We'll discuss that. So now we have known the binary values of these things. If you look carefully, we have one bit in the even position here. 0, 1, 2, 3, 4. Okay, like that the index follows. So 0 is a even position for us, right? So similarly, this even starting from even, and this is starting from odd. Okay, this is starting from odd position. We have one values here. In even position, we have one values here. Now the use of having these values is if we do a AND operation. Okay, if we do the AND operation with the above example, now let's take the even value here 10, 10, and 10. Now, if you do the AND operation, you know the AND operation principle, right? Only when both are 1, it will give 1. If only one is 0 or both of them are 0, then we get 0. Now, using this AND operation, we will only get even position value, which is 0, and here 1, 0, 0, 0, and 0. See, this is the answer earlier we have discussed. We have taken visually this as a even bits, right? This is the even bits values. So we got the answer of the even bits here. So this is the even bit value. Now we have to shift it. Okay. Now we have to shift this value. Then we get 0, 0, 0, one more 0 and 1. So for even bit value, we have to right shift. Okay, we have to do right shift here for even. Right shift only one bit we have to shift by using the right shift operator. Okay, then we get the 001 value for even position values only. Similarly, for odd position value, let's do an AND operation again. Let's do AND operation with the odd position. Okay, now let's take above example 0, 1, 0, 1, 1, 1. Now let's do AND operation with this number. So this binary value of the odd position value is 0, 1, 0, 1, 0, and 1. So this will give us the odd values. So the odd bit value is 1, 0, 1, 0, and 1. Okay, this is the value we got by using the 0x555 value doing a AND operation. So now we have to shift this. We have to shift it to the left. Okay, this will be the left shift here. We'll be doing left shift for this for odd values. For odd values, we have to do left shift. If we do left shift, one bit will be shifted to the left side. Only one bit we have to shift. So after shifting one bit for every position, we get the answer 10, 10, 10. So this is the answer we get. Now after doing left shift and right shift above, now we have to combine these values. Okay, we do or operation between this. In between this, we get what? We get 10, 10, and 11, and this will be equal to 43. So this is the approach to this question. If you still haven't understood, let's have a look at the code, and I hope after looking at the code your doubt will be almost clear. If you have any confusion, just pause the video again. Let's move on to the coding part now. Let's go to the Geeks website and let's see the code. We are inside the Geek websites. Okay, now what we are doing is we are doing an AND operation with the 0xAM. So this will get us all the even bits in the value of n. Okay, we'll get all the even bits here. Similarly, for odd bits, we get all the odd bits here. After getting even bit values and odd bit values, for even bit we'll be doing a right shift. So we're doing right shift with by only one. Okay, we're doing only one right shift, and in odd bits we're doing one left shift operation for odd bits. After doing that, we are combining those using OR operation. So after that, we get the result 43 according to the left side example here. So I hope after seeing this question, your doubt must have been cleared. If still it is not clear, you can just use your own compiler and see what values are coming using the print operation here. You can see what values are coming and you can practice what is happening inside and see for yourself. If you have any doubts, just leave a comment below. If you like the video, please give a like and subscribe with all of the accounts that you have. And thank you for watching. Let's meet in another question.